Good morning, children. Now we'll do two important problems. They are very important for 7 marks. They are based on the solid cube. So we'll draw a cube like this. First you draw a square, another square like this, and then join these sides. So they become the vertices. Now you take x-axis this way and y-axis, and this is z-axis. So you can take x, y, z here, but it should be in this direction, in the anti-clockwise direction, in the right-handed system. So x, y, z I took like this. So this becomes the origin. Now understand how we write the vertices, the coordinates of the vertices. Now this point is on x-axis. You have learnt in coordinates chapter, in the first chapter, how to write the coordinates on coordinate axis, x-axis, y-axis, z-axis, and xy plane, yz and zx plane. So here this point is on x-axis. So suppose that this is a cube of side a units. So the length of this side is a. So this side is also a. It is a cube. So here this length is also a. So x coordinate is a. Because it is on x-axis, y coordinate and z coordinates are 0. Now first we'll name others. A 0. Okay, I'll take the points as this is A, B, and then A, B, C, and then D, E, F, and G. These are the vertices. So you have O is the origin like this. A is A0, 0. Now where is this point B? B is in XY plane. B is in XY plane. So X coordinate, Y coordinate will be there. Z coordinate is 0. So because all sides are equal, this will be X distance is A, X distance is A, Y distance is also A, Z distance is 0. Now where is this? This point F is on XZ plane. This is XZ plane. So X will be there and Z will be there. Y coordinate will be 0. So like this we write the coordinates of all the 8 vertices. Okay, now where is this point? It is on Z axis. On Z axis, Z coordinate will be there. X and Y are zeros. So X, Y are zeros and this is E. Now this point is in space. So its coordinates will be A like this. Now where is this D point? D point is backside. So that is in YZ plane. In YZ plane you will have Y and Z. X will be 0. So Y is A and Z is also A. So like this we write the coordinates. Once again, you try to understand how to write the coordinates. First you draw the cube, 2 squares you draw, join, and then take origin, x-axis, y-axis, z-axis. On x-axis, x coordinate will be A, y and z are 0. On y-axis, this point is on y-axis. So it is 0, A, 0. Y coordinate will be there, x and z are zeros. So now this is in yz plane. So y and z will be A, x is 0. This is on z-axis. On z-axis, x and y are zeros like that. So this is in xz plane. So like this we write. Now there are 4 diagonals for a cube. What is a diagonal? Diagonal is the line segment joining one vertex and another vertex which is on the opposite side. If you join EC, it becomes the diagonal of that side. So if you join E and B, it becomes the diagonal of the cube. So EB is one diagonal. And if I take O, then G will be another diagonal. So OG is another diagonal. If I take A is this face. A is in this face. So it should be D. So AD is another diagonal. When it is AD, I should have FC. FC is another diagonal. So these are the 4 diagonals of the cube. Now we'll find the direction ratios of these 4 diagonals. So what is the direction ratio of EB? Just x2 minus x1, y2 minus y1, z2 minus z1. So the direction ratios, drs of EB, the drs of EB are a minus 0, that is a, again a minus 0, a, and then 0 minus a, that is minus a, like this. Now the direction ratios of OG, origin, O and G, origin. So a minus 0, a minus 0, a minus 0. So that will be a, like this. Now the direction ratios of A and D. A is here, D is here. So subtract 0 minus a. So minus a and then a minus 0. y2 minus y1, z2 minus z1, like that. So a and then again a. So next, direction ratios of F and FC. So this is F and C. C is here. So it will be a minus 0. That is a, and then 0 minus a, and then a minus 0, that is a, like this. So actually you can also find the direction ratios of FC means it will be C minus F. You can subtract, but you can write x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. Anyway you can write. But it is better if you have one sign minus in all direction ratios. In the direction ratios, you see that one is negative, other two are positive. Then it will be easy to solve the problem. So first write like this. Now you have two problems based on the cube. The two problems are: find the angle between any two diagonals of a cube. So when you know the direction ratios of any two diagonals, you can use that cos theta formula and find the angle between them, taking them as A1, B1, C1, A2, B2, C2, like that. You can take any two diagonals. Among the four diagonals, you can take any two diagonals and find the angle between them. That is one problem. Another problem is, in the cube, there is a ray like this. The ray makes an angle. This ray, you have four diagonals, no? You have FC one diagonal, FC is one diagonal, and then OG is another diagonal like this. Then AD is another diagonal, and then FB is another diagonal. So these four diagonals, AD also I should join. Okay, so all the four diagonals make some angle. One diagonal, this diagonal is making some angle alpha. Second diagonal is making some angle beta. Okay. Third diagonal is making some angle gamma with the ray. And another diagonal makes an angle delta. So alpha, beta, gamma and delta are the angles made by this ray with the four diagonals. Then find the value of cos square alpha plus cos square beta plus cos square gamma plus cos square delta. That is the problem. Find the value cos square delta. So what we do, we'll find the cos theta formula. So for this line, for this ray, we'll take the direction cosines. That will be easy because L square plus M square plus N square will become 1. L square, if we take direction ratios of the ray as some unknown values, A1, B1, C1, then they will not satisfy this condition. No? So if we take this direction cosines, then this value becomes 1. And in the formula of cos theta, A1, A2 becomes L1 plus B1, B2 becomes M. And then C1, C2 becomes N. Because direction cosines are direction ratios. You can take them as direction ratios only and write the formula. In this root values, here L square plus M square plus N square you can write as 1. And then A1, B1, C1 will be these values and you can easily simplify. If these three are three different unknowns, then it is difficult to simplify this and also find the value. So in this problem, so the problem is like this. You have a cube, there is a ray which is making angles alpha, beta, gamma, delta with the 4 diagonals of the cube, then find the value of this cos square alpha plus cos square beta plus cos square gamma plus cos square delta. That is the problem. This problem is very important. For understanding, it may take time, but steps are very simple. You just draw the cube, then you just find the direction ratios of all the 4 diagonals, and suppose that the direction cosines of the ray as LMN satisfying this condition, and then just write cos alpha formula, cos beta, cos gamma, cos delta, simplify, and then find the value that gives you the value as 4/3. That is a. Now we'll write the solution neatly and then I will explain. So we discussed the problem. Now this is the solution. See, the question is, if a ray makes angles, if a ray means half line, makes angles alpha, beta, gamma and delta with the 4 diagonals of a cube, then find the value of cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So as we discussed, this is the cube, right? That red one is the back side, blue one is the front side. So this is origin, this is on x-axis. So you just write the coordinates accordingly, because this is in xy plane, x and y will be there. This is in yz plane, this is in xz plane, xz will be there. This is in this point D is backside, no, so it is in YZ plane. So Y and Z will be A and X is 0. So like that, G is in the plane, so A are the coordinates. So let OA, B, C, D, E, F, G be the cube of side A units. Let O be the origin. So you have written the coordinates, so you just write the direction ratios. So the direction ratios formula is x2 minus x1, y2 minus y1, z2 minus z1. So for all that 4 diagonals, you write the direction ratios. Now you consider a ray. Consider a ray with which makes an angle. So suppose that you have a ray like this. This is the ray. It is making, so this one diagonal I will draw. So this is EB is one diagonal. Okay, this is making an angle alpha. This EB diagonal is making an angle alpha like this. Another diagonal OG will make an angle beta like that. So all the 4 diagonals will make 4 angles with this ray. So the direction ratio cosines. For this, the direction cosines are LMN such that L square plus M square plus N square is equal to 1. Okay, so now you mention that also be the direction cosines of the ray making angles respectively with the 4 diagonals. Then this satisfies this condition. Now find cos alpha. Cos alpha formula is A1, A2, so on. A2, B2, C2 are the A1, B1, C1 are the direction cosines same with the 4 diagonals. One diagonal is OG, another one is ray. So angle between OG and ray is alpha. Angle between AD and this ray is beta. Angle between BE and this ray is gamma, like that. So write the formula A1, A2, so on. This is the formula. So A2, B2, C2 will become LMN. They are also the direction ratios of the ray. Cosines are always ratios, but ratios cannot be cosines. So cosines can be considered as ratios, so we substitute it. And here this becomes 1. So this is 3a square. Root 3a square means root 3 into a. Root a square is a. A gets cancelled. So you substitute. Now the same way cos beta. Cos beta here you will have minus. So minus L. A gets cancelled. So you will have like that. Similarly for cos gamma and cos delta, whatever is negative sign here, that will be negative in the cos gamma and cos delta. Like that. So as I said, the direction ratios of BE, when you take the direction ratios of BE, you see that you subtract, if you subtract 0 minus A, 0 minus A minus 0, you will get 2 negatives and 1 positive. Just avoid that. You can take that way also, but just avoid, so that if you have only one negative sign, it is easy to simplify these values. Now write cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So you know a plus b plus c whole square, a square. You take LCM as 3, 1 by 3 and then take 1 by 3 common. LCM is 3. So 1 by 3 you take common, just expand this. This becomes L square plus M square plus N square plus 2AB plus 2BC plus 2CA like that. Here also 2AB becomes minus 2LM. 2BC is 2MN. 2CA becomes minus 2LN. Like that you write the answer. So you will get 4 times L square, 4 times M square, N square like that. And so this is equal to 1, so 4 by 3. So the value of this is 4 by 3. That is the answer. So this problem is very important for 7 marks and you can easily solve the problem. These are the steps. Okay, now next problem is find the angle between two diagonals of a cube. So next problem is find the angle between two diagonals of a cube. Two diagonals of a cube. So this is the problem. So what we do is, we'll just take the same figure. Again you draw the same figure. You don't need this ray now. So this is the figure. So you take any two diagonals here. All 4 diagonals are not necessary. Any 2 diagonals are enough. Suppose I take the first 2 diagonals. So these are the direction ratios of the first 2 diagonals. Now suppose that let theta be the angle. Let theta be the angle between the diagonals. You must find the angle between 2 diagonals, any 2 diagonals. So we'll take these 2. So let theta be the angle between the diagonals. Angle between the diagonals. OG and AD. OG and AD. Then you can have the same formula. Then cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by root of same formula. Now just to substitute. So what is A1 A2? So these are A1 A2 B1 B2 like that. So A1 into A2 is A into minus A. A1 A2 plus B1 B2. A into A. Plus C1 C2. Again A into A. By root of A square plus A square plus A square into root of minus A whole square plus A square plus A square. So this is minus A square plus A square. So minus A square plus A square plus A square by, this is 3 times A square. So root of 3A square into root of again 3A square. So A square gets cancelled. So it is A square by 3A square. That is 1 by 3. So now you will write. Therefore, the angle between the 2 diagonals of a cube is theta is equal to. So therefore, the angle between the 2 diagonals. Angle between the 2 diagonals. Any 2 diagonals you can take. You will get the same value. So the angle between the 2 diagonals of a cube is theta is equal to cos inverse of 1 by 3. Cos inverse of 1 by 3. This is your answer. So like this we do. So the same figure holds good for even this problem. These steps are all same. Just one angle you will find. Okay. Now next problem. Yes, next problem. A, B, C are 3 points and D is the foot of the perpendicular drawn from A to BC, and then you must find the coordinates of D. In 2-dimensional coordinate system, you have a formula like this. You have x1, y1, a point, and then this line is ax plus by plus c is equal to 0. If the foot of the perpendicular is h comma k, then you have the formula as h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. So you have the formula, and then using that formula you are finding the coordinates of the foot of the perpendicular. But here we don't have any such formula. So what is the procedure here to find the foot of the coordinates of the foot of the perpendicular? So what we do is, first we'll assume that D divides BC in the ratio k is to 1. You can take m is to n, but instead of taking two unknowns, it is better to take one unknown as k. Then it is easy to find the ratio and solve the problems. So suppose that D divides, D is the foot of the perpendicular drawn from A to BC. You are given these points. So suppose that D divides, let D divides BC in the ratio, D divides BC in the ratio k is to 1. Then what are the coordinates of D? Then D is equal to mx2 plus nx1, mx2 plus nx1 by m plus n. So that is the formula. So it is 2k mx2 plus nx1 by m plus n. Then again my2, that is minus 3k plus ny1, 1 into minus 11 by m plus n. Then again mz2, so that is k, and then nz1, so k plus 4 by k plus 1. So now we'll find the coordinates of D like this, and I'll number this as 1 because we need it again to substitute k, value of k. Now what is it? We have AD is, now we'll find the DRs, direction ratios of BC. We'll find, now that we know the coordinates of D in terms of k, we'll find the direction ratios of BC and the direction ratios of AD, and then we have the formula A1, A2 plus B1, B2 plus C1, C2 is equal to 0 because they are perpendicular. So using that formula, by substituting, you'll get k. After getting k, again you substitute in this, you will get the coordinates of D. So that is the procedure. So the direction ratios of BC are, what are the direction ratios? I'll name them as A1, B1, C1. That is 2 minus 0. 2 minus 0 is 2. And then minus 3 plus 11. Minus 8. Okay, I'll write like this. 2 minus 0. Minus 3 plus 11. 1 minus 4. So what is it? 2, 8, minus 3. So these are A1, B1, C1. Now we'll write the direction ratios of AD. Direction ratios of AD are, this is x2. x2 minus x1 means 2k by k plus 1 minus 1, minus 3k minus 11 by k plus 1 minus 8, k plus 4 by k plus 1. Z2 minus Z1 is 4. So now we'll simplify. So this is equal to 2k minus k, that is k minus 1. K minus 1 by k plus 1, and then minus 3k minus 8k, 9 to 11, minus 11k, and minus 11 minus 8. So minus 19 by k plus 1. And here k minus 4k, minus 3k, and then 4 minus 4, 0, by k plus 1. So this is your A2, B2, C2. These are the direction ratios of BAD. Now BC is perpendicular to AD. So it implies A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now just to multiply, A1, A2 means 2 into k minus 1, 2 into k minus 1 by k plus 1, plus 8 into minus 11k minus 19 by k plus 1, and then minus 3 into minus 3k by k plus 1 is equal to 0. Now if you take a plus 1 as LCM and simplify, you will get so this implies 2k minus 2 minus 88k minus 152 minus 152 plus 9k by k plus 1 is equal to 0. So that means 88, 9, 11. 88 minus 11, 77. So minus 77k, 152, 154. So minus 154 is equal to 0. So that means minus 7k is equal to 154 by minus 77. So 11 1's 11, 11 4's 44. This is 2 only. So minus 2. 2 times it goes. So it is equal to minus 2. Now substituting the value of k in 1, substituting in 1, we get d value. We get d is equal to, write k as minus 2. So it is 2 into minus 2. 2 into minus 2 by minus 2 plus 1 and then minus 3k. Minus 3k is minus 3 into minus 2 plus 6. So 6 minus 11 by minus 2 minus plus 1 and then minus 2 plus 4 by minus 2 plus 1. So now when you simplify, it is minus 4 by minus 1, minus 4 by minus 1, minus 5 by minus 1 and then it is 2 by minus 1. So that means the coordinates of C are, therefore D is equal to 4, 5, minus 2. So this is your answer. So the coordinates of D are, the coordinates of D are 4, 5 and minus 2. This is the procedure. So you find the coordinates of D, assuming that D divides BC in the ratio k is to 1. So suppose D divides BC in the ratio k is to 1. Remember this procedure. It is not like in 2 dimensions. It is totally different. Find the coordinates of D and then find the direction ratios of BC and AD. And since they are perpendicular, they satisfy this condition. Substitute in the condition and find out k. After getting k, you can find the coordinates of D. So like this, we do the problem. This is again very important for 7 marks. Now we'll continue with the problems in the next class.